Hello and welcome to this video where we get to see the solutions to the exercises that were given in the previous lesson for naming branched alkanes. So without wasting time, let's go into the solutions. We have this structure on the screen right now. Step number one would be to identify the longest continuous carbon chain. So we can count from the left to the right, 1, 2, 3. We can also decide to count from the right to the left, 1, 2, 3. We can even decide to count from the left and go up, which is 1, 2, 3. We can decide to count from up, down, 1, 2. Any direction you want to start from is allowed. Just make sure it is the longest continuous carbon chain. So counting, we have 3 carbon atoms, which gives us the parent name prop. Now the question is, what direction can we count from? We can count from the left to the right. That means our branch will be this guy and it's on carbon number 2. If we count from the right to the left, 1, 2, 3, this guy would also be on carbon number 2. So we can decide to count from either the left or the right. Our branch is CH3 and it is located on carbon number 2. So writing the name becomes 2-methyl, and then we add the parent name, which is propane. That is the name for this guy, 2-methyl propane. Ahead on to the next. We have this guy on the screen right now. So what do? We have the first step, which is to count or identify the longest continuous carbon chain. 1, 2, 3, and 4. We have 4 carbon atoms, which gives us the parent name BUT. Now the question is, are we going to be counting from the left to the right? Or are we going to be counting from the right to the left? Counting from the left to the right, which we just did, gave us this branch, which is located on carbon number 2. If we count from the right to the left, however, this becomes 1, 2, 3, and 4. So that means our branch will be located on carbon number 3. The first style of counting gave us the position of the branch to be on carbon number 2. The second style of counting gave us the position to be on carbon number 3. And we always want to count in such a way that our branch will be given the lowest number possible. Between the number 2 and the number 3, which one is greater? Number 3 is greater. So that means number 2, which is lower, would be the one we'll give preference to. So that makes us count from the left, 1, 2, 3, 4, to the right. So our branch is on carbon number 2, and it is a CH3, which is called methyl. So to identify that, we'll write the full name, which is 2-methyl. And then we'll write the full name or the parent name, which is 4 carbon atoms. That gives us butane. 2-methyl butane. So that's it for the second one. The third question says, can you draw the structure of 2-methyl propane? Well, to draw the structure, the first thing you need to do is to look at the parent name. The parent name is propane. Propane means that it has 3 carbon atoms. So let's draw the structure by starting with the carbon atoms. 1, 2, 3. You can see how I drew the structure. 3 carbon atoms. The next thing to do will be to look at the prefix or the substituent or the branch. 2-methyl propane. 2-methyl propane is telling us that on carbon number 2, there is a substituent or there is a branch, and this time it is called methyl. So let's identify carbon number 2. This is carbon number 2. So it means it will have a branch which is methyl, and methyl is written as CH3. So can you see how the branch was identified? Let me draw it one more time. CH3. Now the next thing to do would be to fill up everything that is remaining with hydrogen. So I just come over here and put my hydrogens to fill up what's left. H, 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 H. Now, some people might decide to go a step further to condense the structure a bit, and then they decide to write something like this: CH3, CH, and then CH3. This is also correct, okay? We're just simply bringing all the hydrogens together. This is 3 hydrogen atoms. That's why we have CH3 over here. This is just 1 hydrogen atom. That's why we have CH here. This branch is identified here as well. And then these 3 hydrogen atoms are what I identified over here as CH3. Now the next question says, why must we number the chain? Well, I'm going to be engaging you for this question. I want you to tell me yourself, why must we number the chain? Let me give you a hint. The chain, the number of the chain determines the root name. Okay, let me go ahead and answer the question. I've already given you so many hints. Okay, we number the chain because the number of carbon atoms in the parent chain gives us the root name, and without the root name, we cannot accurately identify what compound we are dealing with. Then we have this structure on the screen right now that starts off with this. So how do we name this? Well, we identify the longest continuous carbon chain. So we have 1, 2, 3, 4, and 5. If we count from the left to the right that we just did now, this becomes the branch, and it's located on carbon number 2. If we count from the right to the left, 1, 2, 3, 4, 5. This is also the branch, and it's located on carbon number 4. So we would count from the left to the right in this case, because that would be the direction that would give this guy, which is the branch, the lowest possible number. So counting from the left to the right, we have 5 carbon atoms, which gives us the root name PENT, pent. Now we have this branch over here located on carbon number 2, and the name is methyl, CH3. So in order to identify the name, we have 2-methyl, and then we add the parent name, which is, or the root name, which is pentane, 2-methyl pentane. Did you get value for today's video? I know you did. So do well to like, share, and subscribe for more content coming your way every day of the week. Up next, we're going to be seeing how you can name alkanes. I want you to be seated. I want you to be at the edge of your seats, because it's going to be nothing short of interesting. I look forward to seeing you in that video, and up until then, stay blessed.